Well, let's see here. Right now, where we stand, we are like this close to being. I could put these in a cabinet, have them running in Class C, and probably like no time flat. But you guys know me, I'm a little bit more anal about what we want to do here. So one of these is going to get finished before the other. One of these is going to be sideband, and the other one's going to be a Class C box. There's a gentleman that is coming from the other side of the United States through here to drop his load. 2 anal references in friggin' 5 minutes. He's got to go and run up to Seattle to drop off a load, and he's going to be coming through here, and he wants to pick up a Class C 4-pill. And I said, I happen to be building one of those. So let me show you how precise this this decision-making process is. Eeny, meeny, miny, mo. Catch the big boobed woman by her toe. If she will not let you touch her nipple, then say eeny, meeny, miny, mo. Okay, it's going to be the Class A box, or Class C box. We'll come back to the other one. Right now we're going to put all of our attention into this, and let's see how quickly we can get this done. Okay, so let's see here. Done. This is our pass-through tune. We're going to show it to you on broad spectrum. So what we're looking at here is a SWR. At the bottom is 0, which is almost impossible to achieve. All the way up at the top is infinite. From this corner here represents 0 megahertz, and from this corner here represents 53 megahertz. Right in the middle is like channel 2627. That is our SWR response across the entire spectrum. And it's currently sitting at a 1.051. So I'll consider that a win. I don't know about you guys. But let's get this out of the way. Now, I'm getting ready to release a video about coax length and how it makes a big difference, and how, especially in a mobile, huge difference. And the coax's reactance to the circuit, or how it interacts, I guess would be the best way to put it. Even though the term is reactance. What does coax add and subtract, or how does it affect the signal path from, let's say, radio to driver, and how that jumper that goes from your radio to your driver, and your driver to your big box, or your driver to your next driver to your next driver, your big box, how it all interacts in the circuit. We use that same very powerful network analyzer I own, and we show how it goes in resonant lengths, and how each piece of coax, depending on its manufacturer and dielectric insulation properties, how it affects each single step of the process, and how you have to compensate for that based off of manufacturer and insulator. I think you guys are going to think it's, well, it's, look, this is one of these topics that's always been a hot source of debate, even though it's not something that we can debate. All right, everybody has their own opinion and their own little verbiage, and they've got their own way of calculating the coax reactance. Or I just put it on the machine, test it, and say it needs to be this long. Take the question mark out of the air, you know what I mean? So the jumpers that I'm using here are 6 foot, right here. And then from here down to the dummy loads, another 6 foot jumper. All my jumpers on my bench from the end of each one of these meters down here to the amp is like 18.4, 18.5 feet. So 18 feet 4 inches, 18 feet, 18 feet 5 inches, roughly. And it's been that way for years. because that is the electrical length that this piece of wire needs to be for us to have a perfectly flat input SWR into this amp. Because electrically, this coax is not reactive in the circuit, as it's not adding more inductance or capacitance to the circuit. It's at what they call a nulled neutral reactance point. Anyhow, I'm going to have a whole video coming out explaining the minutia of that nightmare of conversation. Now, I don't know what I'm going to get for numbers out of this. I might have to come back and tweak the tune just a little bit. But I've built so many of these here lately that I'm fairly confident that I can hook this up and have some decent results without fiddly farting around with it first. But we'll see what happens. Okay. Let's get a baseline of measurement going on here. As we can all see right here, we're on 12 volts. It's a 1,000 watt slug and peak, 1,000 in average. And of course, as always, my ever trusty and steady 5 watt slug in reverse, back from my real true Bird 10,000 watt dummy load. We're going to start out, we're going to use the, where am I here? The 2950. We're going to use my very first Bird element that I've ever owned, was this 5 watt slug in reverse here. 18.5 feet of coax roughly, down to the back side of the box. And we're going to look at the RF stability, or the term that I use, pass through. And then there's, man, I've heard people refer to this in like 15 different ways. The reactance of the circuit for the RF to pass through, come out, go through the 6-foot jumper, read it at the null point, and then down to the next null point. So we're dead in the middle. Null point, nulled out. So that means that there's no reactance to this point of measurement, and then no reactance from that point of measurement down to the dummy load. But as a length, as a total length, this has a high angle of reactance to it. Otherwise, like what you'd run into in the real world. Okay, first let's shut the amp off. Hello, 1, 2, 1, 2. So let's look at what we're putting into it for drive on 12 volts. Hello, 1, 2, 20 watts. Now let's come up here and let's look at this watt meter. Hello, 1/10 of 1 watt. So that's not too bad. Let's go ahead and we'll fire the box up. Hello, 1, 2. I think I seen a little whiff of smoke. And we're down on power. But the input tune's all right. Hello, 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 hello. Let's bust out the FLIR. I think something's getting hot and it's saying, hello, I'm not working right, because we are not right on power, but the input tune is perfect. Let's go over here and take a look for her. Do-do, do-do, do-do. Do-do-do-do. Do-do-do. Waiting for this to boot. Give me a second. Right. I've got a very hot output balancing resistor. So that tells me that either my capacitor's gone bad. Why does this battery keep popping at me? That's scary. This battery is what powers my monitor. Oh, it is very warm. This battery sitting by itself is 85 degrees. Let me deal with this possible lipo bomb, and I'll be right back. mean, this thing's popping and cracking like it's pushing against the plastic. That's interesting. I just took the battery outside and set it down, and we'll see if it blows up over the night or not. Okay, so our output balancing resistor here. Hello, 1, 2, 1, 2, 1, 2. Just turn this around so you guys can see it and be involved too. Is getting warm. Hello, getting 300 watts out of it. So that tells me either my output capacitor is bad, and the reason I'm not overly looking back here is because with the FLIR, when you turn the amp on and put it in operation, the transistors all heat up. And if you have one that's out of balance, it's not going to make any heat. Or if you have one that's firing really low, like it's got something shorted or a little bit of schmutz or something, it'll show up as different signatures of heat. And then your input balancing resistor will also warm up, and it'll show up as a high input SWR. Well, right now, it's not bad, but this isn't great. Check this out. Hello, 1, 2. Hello, 1, 2. That's still, for a 20 watt radio hitting it, that's an acceptable input reflect, okay? But we're gonna drive this with a striker and we're gonna hit it a whole lot harder. So, simple problem solving. Let's go check the value of this output mica, or this metal clad, and let's make sure it hasn't gone south. It ended up being, not the output tuning capacitor, but over on this side, on the input, there was a little tiny piece of copper trace left in between the two pill strips. It happens. It was pretty quick to figure it out. It took 5 minutes. So, okay, now we're up on 15 volts, and let's go over here and let's take a look at this. First, let's look at drive. Hello, about 30 watts. And that 30 watts is now 580 watts worth of love. Before I put that away, let's go up here and look at this. Now this has changed as well. Hello. So with 30 watts going in, we have 2/10 of 1 watt coming back. Hello. Made about 200 bird. Okay, let's hook up the derail striker 955. Let's pan back out. That way you guys have visually got some cues of watching me work. We'll disconnect the 2950. We'll throw it aside. We'll grab the ever venerable black coax, which has made its appearance in no less than 1,000 YouTube videos at this point. It seems like. I call it the black coax because black's my favorite color. It's all the colors mixed together. And it's got a piece of black heat shrink on it. If you guys have never noticed, the 2950 has got a piece of red coax on it. The Striker 490 has got blue heat shrink on it, okay? And so on and so on and so on. That way, when I'm shooting a video, all I gotta do is look down and look for the color and pull it, and I know that's where it's attached. I don't have to look at labels or nothing. But then on top of that, there's labels on everything, so call me inattentive. Okay. Hello. There's 1,000 watts, no problem. Hello. 1, 2, 1, 2. Beautiful. 1,000 watts peak, no problem. Let's take a look at the front of the Striker radio bridge here. Hello. 1 bar. 5 watt slug and reverse. Hello. 3/10 of 1 watt, which is not enough to piss off any of the RF gods. Hello. No problem. No problem at all. I'm happy. I'm peaceful with this. So, the only thing really left to do before I can take it to this guy, if I end up meeting up with him today, is to put the case and the fan on it. It's already got its labels and more labels, and so let's do the fan. Well, it's all cleared, and let's put a screw or two in this thing, and we'll give it a whopper. What for whose does it? I test every amp with the lid on, fans on, because I had one experience where I shipped it out of here and the guy went to key the amp and it killed all the fans. So, hello. Look at that thing, just lazily going over 1,000 watts like it's no big deal. Hello. One, hello. About 1,200 watts plus with 120 watts going in, so. Okay, let me get the rest of the screws in this cabinet and I gotta hurry off and go meet this guy. And then we'll come back, we'll finish the other one. Okay. So this one's all done. Interesting. Run. Here it is. Oh, stay stable coax connector. These Chinesium end adapters. It's like I talked to the guys at DeSpace and I said, can you do me a favor and put PL259 connectors on there so it matches up with everything that I need? And they said, no, we don't do that. We're going to do N and that's it. So have a nice day. So these adapters every once in a while freak out. As we can see, right in the middle of the band here. So from 25 megahertz, which is like 100 channels below 1, to a couple hundred channels above 40, the pass-through tune is perfectly flat. And that's once again measuring the RF coming out of the connector, going down the coax, going through the amplifier, and then out to the line section and bird dummy load. So, okay, let's hook it up and run this little thing real quick. And just one more quick look on the inside. Yeah. Let's run it. Let's see how it does. I cannot get over how much the cost of everything has gone up lately. The cost of ferrite, the cost of Teflon wire. But the only thing that really hasn't been price adjusted yet is the cost of the cabinets. The cost of resistors, the transistors have gone up a little bit. The phenolic has gone up. The wire, shoot, this wire is just, it's almost doubled in price. The coax connectors have gone up 75 cents a piece or 50 cents a piece. I mean, even the little plastic insert for the variable potentiometer hole is this. I just bought these the other day. The remote plug jacks. Everything's gone up. It's ridiculous. I haven't built a Class C box in a while, so I'm going to build 2 of them. This does not have sideband in it. This is an AM only monster, just like its other one, the partner. See, this one I believe is 30. The other one was 29. I mean, the cost of 316's gone up 35 cents a foot, or 30 cents a foot, right? These fans, the sun-on fans that I use, they've gone up about $2 or $3 a piece. I wish you guys knew how much time it took to peel the plastic, prime these, and then paint these for the outside of the amps. So anyhow, what I'm going to ask for this is $850 as it sits. And if you want sideband added to it, for years I charged $35 or $40 for the sideband. Well, here's the problem. These little micro relays that I use to switch the bias on and off, these guys, these have gone up by about $1.50 a piece, and these have gone up by $2 or $3 a piece. Okay. On top of the cost of the diodes, and then the resistors. Oh man, don't even get me started about the resistors. Those 10 ohm 15 waters. I thank God, because about a month ago we couldn't even get those. And they said the lead time on them was like 16 weeks if I ordered more than 1,000. Well, they had a lot of about 500 of them show up. and I bought quite a few of them because I didn't want to run out. But those have gone up, I think, 25 or 30 cents a piece. So after it's all said and done, I can't do the bias for $35 anymore. It's like 60 or 80 bucks. It just is what it is. But I'm just saying, if somebody wanted me to add bias to it, that means I'd have to take the whole thing apart and run all the wires underneath, and I could do it. It'd just be a little bit more money. You know what I mean? So $8.50 is where I'm at with this, and that includes shipping in a shirt. So it is what it is. Okay, let's go over here. And let's do all of our units of measure, of course. 1,000 watt silicon peak, 1,000 average, 5 watt silicon reverse. Back from the bird, 10,000 watt dummy load. We'll turn the amp off. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Okay, so we're hitting this with the Stryker 955 D-rail radio. Hello, right over to the stop peg. Not banging it on the stop peg, but we are hitting it. Let's go ahead and we'll turn the amp off. Let's go up here. Let's spend a little bit of time looking at these two meters. Okay, so this is a 5 watt silicon reverse between the Stryker and the bench radio. Of course, anybody that's ever watched any of my YouTube videos knows what I'm talking about now. Come on, there we go. Okay, and then the hardest SWR bridge in the world to try and think everything's happy. First, we're going to look at pass-through tunes. So that's the RF coming through the amplifier to the dummy load. Hello, 1 1 1 1 1 1 1 1 1 1. So we're seeing about a 1/10 of a watt with the reflect, which is great. Let's go ahead and turn the amp on. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2. So about 2/10 worth of a watt of reflect, and absolutely nothing over here on the Stryker. So 1 2 1 2 1 2 1 2 1 2. Meanwhile, we're over here railing this thing against the stop peg. Hello, hello. It's running. Needless to say, I'm going to call this a win. So you guys all know the drill by now. You guys all know the drill by now. First one to call, text, or reach out to me about this gets it. And it's on to a new home. Let me slap the lid on it, and let's test it and make sure the fan's going to stay working in operation, which I know it will. And we'll wrap this thing. Okay, fan's working. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. No RF's getting in the fan. Fully tested, ready to go out the door. Well, gentlemen, this is Master Builder Class 29 and 30. These are both AM only boxes. These are high drive boxes, which kick ass. And yeah, first one to call me or text me. This one's for sale. The other one, I ended up missing the dude yesterday. I was really hoping to get up with him. He ended up not being able to stay, but he said he'd be back in the next day or so. So we'll see what happens. I might end up being able to get it to him. If not, you'll see me put it up for sale, and it can go on to one of you guys. Gentlemen, on that note, I say thank you. I say thank you to XS, Siglent, McMahon, Bird, Coaxial Dynamics, you know, usual guys. I feel like all I've built here lately is 4-pill after 4-pill after 4-pill, and so on and so on and so on. I got 2 6-pill bases that are be coming up next week. Hopefully I can get them done before Memorial Day vacation. I've also got to take the whole shop apart and clean it and reorganize it because I'm getting ready to take on new work on September 1st. Do not send me anything. You must call before. I'm not taking on any phone calls or talking about taking on work until the 1st of September, and at that time I'm going to give everybody an RO number, which stands for repair order. Okay? If you don't have an RO number on your box, I'm going to send you back your stuff. So don't be thinking, oh, I'm going to send him something. No, don't do that. Wait till September 1st and then call me. I don't plan on actually having any boxes or any projects showing up here until at least the 10th of December. Or September, I mean. So there's a whole process that's going to go along with this. I'm not going to get myself worked into a corner where I can't take on work for 2 years, like what happened the last time I took on work. I mean, 850 pieces of equipment was too much. It was too much. So, anyhow, on that note, gentlemen, you guys have a great day, great rest of your week, or if you're watching this in sometime in the future, I want to say thank you for watching and tuning in. Big shout out to my Patreons. Without these guys down here at BBI Amps on Patreon, I honestly don't think I'd be here. They're the ones that make it possible for me to sit around on the phone half the day and talk on the phone and answer all your guys' questions. And I mean, they're the driving force behind this channel, and to them I say thank you especially. But at the end of the day, I don't get to be here without all you guys. That's the truth. All right, well, now I'm off to go work on building an LTO battery, which of course there's going to be a YouTube video of that, and then I've got to work on the cleanest, nicest, prettiest Glen amplifier I've ever seen. Gentlemen, I'll see you. Click, click.